Hello everyone. Today we're going to be talking about materials, shaders, and texturing. Basically anything that is going to give your model a more realistic look instead of that simple gray material that we've been working so far. We're going to give the object the texture, the look of a different material, either metal, wood, stone, bricks, anything you could imagine. But before we start actually putting some texturing in the models that we already created, let's talk a little bit about shading, about the whole concept of creating materials in Maya. So I'm gonna open the outliner here on the left, and I have some stuff here that I already created to show you guys. First, I put a dome light with a background here. So it's gonna make the scene a little bit more interesting for us to check our materials. And then I'm gonna open my Hypershade here. Here's where we create materials, select materials, and we apply materials in Maya. And I'm gonna dock this here on the side. So looks a little bit easier for us to see what is going on. And notice that when I click the material, I don't have that extra window with information that we usually have here. I close that because we can get the same information here in the attribute editor. So it's kind of redundant. So in this way, we have a little bit more real estate to work with our project here. So first, let's talk about basic shaders. So I have here an example of 5 different shaders. Those are the most basic shaders in 3D animation. Those shaders exist in almost every 3D application you can think of, either 3ds Max, Blender, Cinema 4D. Every 3D application will have a variation of those basic 5 shaders. So the first one, this one here, is Lambert material. The Lambert material is the same material that we have as a standard material, that gray material. Every time we create, for example, a cube, usually we have a gray material. That's a Lambert. Here is red because I changed the color. But let's take a look at the material here. It's a very simple material. Has some different channels that we can apply different textures or different effects, and we're going to talk later about this. The main thing about Lambert is that you don't have a highlight. It's a very opaque material. As we can see here, there's no highlight. This was actually the first 3D material, 3D shader we had in computer graphic history. To understand this, let's go back a little bit to like in the 70s when they were still studying 3D graphics, mostly at computer science department. At that time, everything was just a wireframe. And the wireframe was already an amazing progress because in the beginning it was just points in the 3D space, and then they figure out how to create the wireframe. And you still had to work with this. So then after a lot of struggle, they realized how they could create some shading. First, how they could hide the lines in the back, and then how they could create some shading for the object. But it wasn't smooth like this. It was more like when you have the hardened edges, for example. If I go here and mesh display and harden edge. So it was like this. You could see each polygon that makes that sphere. The only way to get rid of that would be to make very, very tiny polygons, but that would be too much for the computers to handle. Nowadays would be a struggle, but back in the day would be almost impossible, even with professional, like gigantic computers they use at that time. So the challenge of the computer scientist guys at that time was to create a way to represent the smooth surface of an object without creating more polygons. And let me go back to the smooth here and soften edge. Okay, so this guy here, Lambert, and Lambert is actually a surname. It was a computer scientist. He figured out the way to do that. He was the first one to figure out. He did some mathematical calculations averaging the normal of each polygon and creating this illusion that this surface is actually smooth when actually it's not. And that was the first shader we had in computer graphics history in terms of 3D. But we still didn't have a highlight. We still didn't have any reflection. And it was a very simple material. Then came the second guy here, the Blinn. The Blinn material, again, Blinn is actually a surname. So he created a more advanced form of material. So the main difference here is that you have some additional attributes here. And the main one would be the specular shading that creates this nice specular highlight here. In Maya, you can change this, make this stronger or less strong. This was a huge advance. Again, like the smooth surface of Lambert, this is a simulation. In real life, a highlight is actually a blurred reflection of your light source. At that time, any real reflection was too computer intensive. They could already do it, but it would take like forever. It was really, really hard on the computers. Keep in mind, a computer at that time, they were still gigantic. We're talking about before the PC micro revolution, and they were much, much less powerful than even your smartphone today. So to do real reflections was a kind of big no-no. So the highlight was just a simulation, basically created like this white blurred point that is directed, it depends on the direction of the light in the scene. So it was a huge advance. And so this was the Blinn shader. Then another guy, Phong, which is also a surname. Phong was if I'm not mistaken, he's a foreigner student, computer science student in the United States, and then he created a more advanced form of shader based on Blinn, but with more options. You had more control about the highlight. You could get a more realistic highlight in comparison to Blinn. And later on, the Phong was made a little bit better. It was improved, and it was given the name Phong E, which is basically a more advanced. It's just a more advanced form of the Phong shader, very similar one. And finally, we had the anisotropic material. This one does not receive the name of the creator. Anisotropic refers to the type of reflection that we have here. You see the highlight is not a little ball, the highlight is long. And you can actually change the angle of that weird highlight. This was created to simulate some certain types of reflections in real life. For example, the reflection of your hair, if you have straight hair, the reflection of those old vinyl record discs, or even the compact discs that we used to use for music. So they all have this kind of weird highlight, and the anisotropic was created for that. So those are very simple, basic types of shader. We can create all of them here going to the Hypershade Maya surface, and you have all those options and so many others here, but you have the basic ones, the Blinn, the Lambert, Phong E, and anisotropic. They are all compatible with the current renderer of Maya, which is Arnold, but they don't work 100%. Some of the channels that we have in those old shaders, they don't actually work with Arnold. If you want a full compatibility, you would have to change back to Maya software, but Maya software it's a really old and slow renderer, so there's no point in doing that. So we're going to be working with Arnold. And so for Arnold, we actually have a different shader. We are going to be working with this. We're going to be working with a different shader, which is the Arnold shader. The Arnold shader does not display correctly in the viewport. You have to turn on the Arnold and press play to have the preview, and then you see the Arnold material. It has a lot of different attributes where you can pretty much simulate all of those basic shaders that I showed before. So you can simulate the Lambert, the Phong, the Blend, and then the Isotropic just here. And we have a bunch of presets if you want to change. Instead of manually trying to change the attributes, this material comes with different presets for the most typical material that you need, like car paint, chrome, clay, etc. So there's a very powerful shading, but it doesn't matter if we're using the Arnold or the basic shaders. We need to do more than just change the main attributes. We need to use textures in the different channels of the materials. So let's talk a little bit about that. So let me turn off the render here and go back to the viewport, normal viewport. So we have 3 materials that we have to plug in different channels of those materials to make the shader more realistic. So let's click here. In this first one, this first object has no material. There has no channels. It's just a basic Lambert. It could be a Phong, but in this case, it's the Lambert one. You see the color is just a flat color, and the same thing with ambient color. Bump mapping is empty. We don't have anything in the other ones, but we all on the right side of each channel, each attribute, we have this checkerboard button here. If you click this, you can apply different types of textures, material effects in that specific channel. What we're going to be doing in this class mostly is to select a file node, and then we're going to select a texture to put in certain attributes. For example, let's get the second one here. The second one is a Phong material, and we only have one texture. We click here in the color, it looks black, but you see we don't have the checkboard anymore. We have a kind of an arrow to the right. It means this is connected to something, and this is connected to a file, a texture file, a .tif file of a brick wall. We can see this connection here if we hover over the material. And which one is this? I think that's the one. We hover over the material and we right click and we select graph network, and we get the material here. Or we could just delete. Let's clean this. Or we can just select the material and click this button here. It's the same thing. Either click here or right click graph network, and you get the shading network of the material. In Maya, we use the term shading network as a synonymous of materials because every material in Maya is made of a network of nodes, and that this is called a shading network. So this main node here, the Phong tree, and let me change this like brick color only. So the brick color only is the material. That's the main node. That's where you have like the main channels here: color, ambient, diffuse, normal camera, etc. This blue guy here is the node that connects the material to the surface of the object. And here we have the connection we just did. We have a file node, and inside this file node I have the texture, and then I have a place to the texture, which tells Maya how to display the texture on my object. So this is very powerful because you can disconnect the connections anytime you want. For example, I can click here and select here, and boom, we don't see the texture anymore, but I can put again, and now we see the texture. We can create new nodes, create new connections. So far so good. You see here no texture, here just the color. Let's see some other channels. The color channel, I think it's the easiest one to understand because it just replaces the color of the diffuse channel with a texture, with any image you want. The second one is a little bit more complicated to understand, which is the specular channel. Look at this one here. It looks pretty much like the Lambert without texture, but if you look in the highlight, you see something different. You can actually see the brick texture, but only in the highlights, only in the reflection. That's because I have a specular map here in this material here. So let's select this material. Let's clean the material we have here in the node editor. To clean, you click the fourth button here and you clean everything. I'm gonna select this one here and I'm gonna graph the network, and we can understand what is happening. If you look here in the attribute editor, we have here in the specular shading, we have a node connection in the specular color. So we can see here is the same thing. We have a file node. Inside this file node, I have a specular texture. The specular texture is different than the color texture. It is, let me click here so it's a little easier for us to see. Instead of having the color of the bricks, it's just a gray texture. It is the same bricks, but without the color, and just black and white representing what is gonna be reflected or not. If it is something is white, you're gonna see the highlight. If it's something is black or closer to black, you're not gonna see it, and then we get this nice effect in the highlight. This is the specular channel. And so the third material is a little bit more complicated. That's what we call a normal map. A normal map, it gives a appearance of more details in the surface of the material, even though we do not have extra geometry. It is still the same material. In the viewport, we have kind of a approximation of the effect, but to really see that in real time, we have to turn on our node, and then we see those nice little creases and details that you would have of the brick in the real material, but we get this just with a texture. So let me graph this so we understand what's going on. So similar to what we did before, we have some nodes connected to a channel here. But in this case, in the bump mapping, I have connected here not a texture, but we have a Bump 2D node, which is a utility of Maya that you can find here in Maya, Utilities, Bump 2D. This node translates a normal map into a normal that Maya can read. In this case, I have to come here, change from bump to tangent space normal. And then here in bump value, I connected a file node. The normal map looks different than the other ones. It uses three colors, purple, kind of pinkish, and green, to represent the 3D geometry that is going to be adding to that object. So this is the normal. Connected here to the normal camera, we get this effect here. So this is the third main material that we need to know, main channel and type of material. The way you're going to be using 3D is that you connect all of three of them in one material to get something that looks more realistic, like this here. So we have two examples here. Let's clean this and let's graph this so we understand here. So we have this foam material, and I connected three of them. I have the color here, one texture, the texture with the colors of the brig, connecting the color attribute. I have the bump mapping connected to the bump 2D with the normal, and finally I have the specular color connected to a texture, to this texture here. So those three textures are creating this more realistic model here. This works well in the viewport, but as I said, sometimes not all channels are going to be working with Arnold. So in this case, it's better to create the materials in Arnold. And we have the example here of the Arnold shading. We don't see the material correctly in the viewport, but if we turn on the Arnold, we have this nice brig texture with all the proper channels here. So this is just a little introduction about materials. I know it is a lot of information, shaders, channels, different types of textures. Don't worry about it. In the next video, I'm gonna teach you how to create some materials and how to apply them to the objects you created last week and give them a nicer look.